Global temperatures have been a topic of interest in scientific analysis for centuries, with the earliest recorded measurements occurring in the mid-19th century. The Industrial Revolution marked a significant turning point as human activities such as deforestation and burning fossil fuels began to alter atmospheric composition, leading to measurable increases in global temperatures. By the early 20th century, scientists observed trends indicating that average global surface temperatures were on an upward trajectory. Key developments include the establishment of temperature monitoring stations across continents starting from the late 19th century. These observations formed a crucial basis for understanding historical climate patterns. The primary driver behind this trend has been anthropogenic activities like deforestation and industrialization, which have released large amounts of greenhouse gases into the atmosphere, particularly carbon dioxide, CO2. Since about 1850, average global temperatures have risen by approximately 1 degree Celsius dietawad. By mid-century, projections suggest that temperatures could increase between another 1 to 3 degrees Celsius globally compared to pre-industrial levels. This rise in temperature has far-reaching implications for ecosystems and human societies. Measurable impacts include an accelerated rate of ice melt at the poles, contributing to sea level rises by up to a meter by 2100, which poses significant threats to coastal communities worldwide. Coral reefs are particularly vulnerable, with projections indicating that as much as 75% of them could be lost within decades due to warming oceans and acidification caused by CO2 absorption into seawater. Major turning points include the signing of the Paris Agreement in 2015, aimed at keeping global temperature rise this century well below 2 degrees Celsius, preferably limiting it to 1.5 degrees Celsius above pre-industrial levels. Implementing strategies such as renewable energy sources like solar and wind power, which have seen a surge in investment, can mitigate these impacts. Despite these efforts, the cumulative effect of accumulated carbon emissions means that even if immediate reductions were achieved, temperatures may continue rising for some time due to feedback loops, such as warming permafrost releasing stored greenhouse gases. In terms of future projections through 2050, global temperature increases could range from 1.4 to 3.6 degrees Celsius above pre-industrial levels. To achieve the more ambitious goal of limiting these increases within this time frame requires sustained and accelerated reductions in carbon emissions. Future research should focus on developing more effective renewable energy technologies and improving energy efficiency measures, while also addressing socioeconomic factors that influence greenhouse gas emissions, such as global economic growth patterns and population dynamics. Implementing policies that promote sustainable practices at local and national levels can help mitigate these impacts and contribute to a cooler future for our planet.